Welcome back. So now we're going to look at using conjugates to rewrite expressions as a fraction and then solving it like a rational expression. Right? And the reason we're going to have to do that is we have an indeterminate limit. Right? So if we have one function is approaching infinity and another function is approaching infinity and we have the difference, we need to figure out who's getting bigger faster, right? And we're going to do that by multiplying by the conjugate. And we're going to do that all the time, right? So this is technically, this is in, come on, there we go, indeterminate limit. Oh, I really should have written that spot. That's my center icky spot. I'll put it over here. Indeterminate limit. Right? So we're going to do it with this. We're going to show the technique with the first one, x cubed minus x squared. And you might figure out what that limit's going to be, but we're definitely going to need it for the second one, where now they're both the same exponent. All right, so we're going to rewrite this by multiplying by the conjugate over the conjugate. And you can do that because you're just multiplying by 1. All right, so I'm going to change the page. Here's the same problem. All right, so we're going to use conjugates to rewrite the expression as a fraction and solve like infinity divided by infinity. And remember that technique, and that is, I should add that in there. Oh, and by the way, you have this in your notes. Divide by the highest power of x. That's the property. All right, so we're going to multiply by, we got x cubed plus x squared, that would be the conjugate, over x cubed plus x squared. All right, so now this will be a rational function. So we have a limit as x approaches infinity. X cubed times x cubed, that's x to the 6th. And then we have to, of course, we're going to have, it's the conjugate. What's going to happen with all our middle terms? Right, so we have x cubed times x squared, the outside terms there, and then we have x cubed times negative x squared, the inside terms. Of course, those are going to be 0. They're going to cancel each other out. Always when you multiply by the conjugate, the middle terms will drop out. It's like a difference of squares, right? If you multiply something minus something times something plus the same something, whatever it is, right? This and this are going to be opposites, and they're always going to just cancel each other out. All right, so we don't have to worry about it. Just as a little reminder. All right, so it's going to be x to the 6th, and it's going to be minus x to the 4th, so multiplication is really easy. And then in the denominator didn't change at all, x cubed plus x squared. And now we'll divide by the highest power of x, so we have the limit as x approaches infinity. Highest power of x, of course, in this case, is x to the 6th. Right, so everybody gets divided by x to the 6th. So x to the 6th divided by x to the 6th minus x to the 4th divided by x to the 6th all over x cubed divided by x to the 6th plus x squared divided by x to the 6th. Let's simplify, everybody. We have the limit as x approaches infinity. X to the 6th divided by x to the 6th, of course, that's 1. And then x to the 4th divided by x to the 6th, that's going to be 1 over x squared. Remember, you can just subtract exponents when you're dividing. X cubed divided by x to the 6th is just going to be 1 over x cubed. And then plus x squared divided by x to the 6th is going to be 1 over x to the 4th. Now we can evaluate. We are at the evaluating stage when this is a limit as x goes to infinity. Limit of the first term, that's 1. Everybody with an x in the denominator is a 0. So this is a does not exist. And actually, the limit as x approaches infinity is actually going to be, and I'll just put f of x here. Now make sure that anytime you abbreviate it like that, at some point you've identified that f of x is x cubed minus x squared, particularly on a AP exam. Otherwise, they won't necessarily know what you're talking about. It's fine for us to doing that here, but on an AP exam, make sure if you want to abbreviate and just use f of x instead of writing the whole function, write in that f of x is that, and then you'll have to keep writing it in. All right, so limit of f of x as x approaches infinity is actually heading off to infinity. But whether you said infinity or whether you said does not exist, those are both correct answers, right? Because if it's approaching infinity, there's no limit doesn't exist, right? It's not heading to any finite value. So not too hard, right? Easy cheesy lemon squeezy, a little multiplying, a little dividing, a little simplifying, we got our answer. Let's do one more together, right? Right, same idea. Now you might have figured out that x cubed and x squared, well, x cubed was probably going to be growing a little faster than x squared, so it probably did not surprise you when we got does not exist as our limit, but now they're equal, right? Because the square root of x to the 6 is x cubed. And the limit we happen to get in this particular problem is not always going to be the limit we get in every single problem, right? It's going to be different. Right, so here we have the limit of the square root of x to the 6 plus 5 minus x cubed as x approaches infinity. Right? Again, this is an indeterminate limit because you've got a radical function that will approach infinity as x approaches infinity. Right? It's going to keep increasing, not particularly fast, but it will keep increasing. And so is x cubed. Now in this case, this is that radical function isn't just any old radical function. It's not just like the square root of x. That's the square root of x to the 6. Right? So that's going to be increasing a lot faster than most of your radical functions. And it's being compared with x cubed. All right? So now let's see what happens here. All right? So we're going to multiply by the conjugate. So that's going to be the square root of x to the 6 plus 5 plus x cubed divided by the square root of x plus 5 plus x cubed. And we'll multiply. We have the limit as x approaches infinity. Square root of x to the 6 plus 5 times the square root of x to the 6 plus 5 is just going to be x to the 6 plus 5. No need for parentheses here because there's nothing to distribute. If that was reversed and x cubed was first, right, then we'd have to put parentheses so we remember to distribute the negative. But no, it's not going to matter. And then the middles will drop out. X cubed minus negative x cubed times x cubed, that's going to be negative x to the 6. Right? In the denominator, we're going to just have exactly what's there. The square root of x plus 5 plus x cubed. All right, now let's simplify. The limit as x approaches infinity. All right, so the x to the 6s are going to cancel out. We've got 5 divided by x plus 5 and then plus x cubed. All right, the greatest, oops, somehow we lost an exponent. Our greatest power, our highest exponent, is x cubed. And that's the same as the square root of x to the 6. Right? So those are the same. So we have, I'm going to go this way now. We have the limit as x approaches infinity of 5 divided by x cubed all over the square root of x to the 6th divided by x to the 6th because it's under the radical plus 5 divided by x to the 6th. Now that x cubed is not under the radical, so let's extend that a bit. Plus x cubed divided by x cubed, right? And I think I can continue this way. I have enough room. Equals the limit as x approaches infinity. And let's simplify that. So I can't really do anything with 5 over x cubed. In the denominator, x to the 6 divided by x to the 6, that's going to be the square root of 1. And then can't do anything with 5 divided by x to the 6. And then plus x cubed divided by x cubed, that's 1. All right, so now, good enough, we can take the limit. We can evaluate now. 5, a constant over x to any power is 0. In the denominator, we have 1 plus 0 plus 1. So we have 0 over 2, and that's 0. Now, every time you do this problem, your limit is not going to necessarily be 0, and not necessarily be does not exist. It can be other things as well. So do not make the assumption, this is not that hard. If you have questions, ask me, but please solve it out appropriately, because this is an indeterminate limit, and we have to solve it correctly and show how we got our answer, so we know for sure what that limit is. I think this is my last example. And if, oh no, I've got one more. Oh good, I have one more. I was hoping I had one more. So far, that's only 2 choices. We had infinity, we had 0. Let's see if we get something else here. All right, so we're going to use conjugates to rewrite the expression as a fraction and then solve. All right, and this is as x approaches negative infinity this time. So we're going to multiply by our conjugate. So that's going to be the square root of x. I love that square root sign there. Nice little bump. X squared plus 2x minus x all over the square root of x squared plus 2x minus x. All right, and now we multiply. So we have the limit as x approaches negative infinity. All right, so square root of x squared plus 2x times square root of x squared plus 2x. That's just x squared plus 2x without the radical anymore. Of course, the middles will drop out because they'll be opposites. So we're going to be, and then we're going to have minus x squared all over. Just what we see, square root of x squared plus 2x minus x. All right, and now we're just going to divide everybody by the highest power of x. And that highest power of x is x squared. Actually, I take that back. Let's simplify first, because it's going to be x, which is the same as square root of x. Let's simplify that first. Equals the limit as, I was so excited to start finding the limit, almost forgot to simplify. The limit as x approaches negative infinity. We have a 2x left because the x squared and the negative x squared, they will cancel each other out. And then we have the square root of x squared plus 2x minus x. All right, so highest power of x is just x. Oops. Square root of x squared. Silly me. Let me just write that a little neater. I guess that's a little better. All right, so we have, I'll come down here. We have the limit as x approaches negative infinity. So we've got, we're going to divide everybody by x, except if you're in the radical, where we're going to divide you by x squared. So we have x squared divided by x squared plus 2x, so that's still under the radical, divided by x squared minus x divided by x. All right, and that's everybody. All right, let's simplify that. So that's the limit as x approaches negative infinity. 2x divided by x, that's going to be 2. And then we have square root of x squared divided by x squared, that's 1, plus, can't really simplify. Oh, I'm sorry, we can't simplify 2x divided by x squared. My shadow was blocking the x. So we can cancel out an x, and now we have 2 over x. And then minus 1. Now we evaluate. All right, and you know what, on this one, I know this one's in your notes, I'm going to write the steps in here so that, and you probably should too, just to help you follow along. And remember, when you're solving it and you go back to look at this and you're like, wait, what did I do? We first multiplied by the conjugate. Right, and then secondly, we simplified. And we simplified right about here. Right? We combine those like terms. And then we divided by highest power of x. Yeah. And then we reduced. And now we're going to evaluate. It came out so nicely the way I wrote. You can actually read it. All right, so that'll help you when you look back at your notes and you're solving this problem. All right, so now we're going to evaluate the 2. The limit of the 2 is the 2. And the denominator there, we've got the square root of 1 plus 0 and minus 1. Well, this one was not as much fun as I thought it was going to be at first, because those are going to cancel each other out, and I'm just going to have, and it does not prove my point, that it will not always be does not exist. Boo-hoo-hoo. If we're thinking which way it's headed, well, one of them has always got to be positive, the stuff in the square root. But it's not that important whether it's heading to positive infinity or negative infinity. Boring. I didn't make any errors, did I? I'm hoping for an error. Does not exist. It will not always be does not exist and infinity. We will see some other kinds. But unfortunately, I don't see an error anywhere. Yep, x squared plus 2x. I didn't write anything down wrong. That's going to be a minus x squared, and that's a minus x. And that cancels, so that's just a 2x. Yeah, and we divide by highest power of x. And yep, so no boo-boos anywhere. So it doesn't really prove my point in that it might not be does not exist or 0. Right? It could be, right, that maybe we might get something else. We'll find out. Or will we always get these 2 answers? Well, we'll have to see in other problems. Right? But that is my last example. But anyway, this is good for having you remember the steps. Bye for now. And if you have any questions on, before I say bye for now, any questions on this, let me know. There'll definitely be some problems in your next homework. Bye for now.